So the redox reactions in the daily life is including the redox reactions are basically chemical reaction involving the transfer of electrons. The word redox is formed from two terms, the reduction and oxidations. They occur everywhere around us, and from breathing to rusting all involve the redox reaction. What is oxidation? Basically, oxidation is a chemical process in which a substance loses electron during a reaction. It can also be defined as the gain of oxygen or loss of hydrogen by a substance. The example of oxidation is iron rusting. Oxidation versus reduction. There is the key difference at a glance. For example, electron movements. Oxidation is the loss of electron while reduction is the gain of electrons. The oxygen transfer, basically oxidation can be defined as the gain of the oxygen, reduction is the loss of the oxygen. There is also a hydrogen transfer, like oxidation is the loss of the hydrogen while reduction is the gain of the hydrogen. There is also a oxidation state, like in addition the oxidation number increase, in reduction it decrease. There is a comparison table that's showing the oxidation and reduction process. Like oxidation is the addition of oxygen. When the two molecule of magnesium, the oxygen is added, so it become magnesium oxide. In the reduction, there is the loss of oxygen, like the two molecule of copper oxide when react with compound, so they release the oxygen atom in the form of carbon dioxide. In the next step, in the oxidation, there is the loss of the hydrogens, like CH3OH. In the oxidation process, it release the hydrogen that form the water molecule, while in the reduction, there is the addition of the hydrogen. For example, when C2H2 react with the hydrogen, it form the C2H6. In oxidation, there is also the loss of the electron. For example, the aluminium during the oxidation have released the three molecule of the electron. While in the reduction, the iron when react with the gain the electron and convert into the iron molecules. So why called redox reaction? Basically, reduction plus oxidation is the redox. One substance loses the electrons, which is the oxidation. Another substance gain the electron, which is the reduction. So the electrons are transferred, not destroyed. So the oxidation and reductions are interdependent. There is the example of rusting of iron. Common example of redox reaction, like iron react with oxygen and water. So iron get oxidized. There is also the role of the oxygen. For example, oxygen act as an oxidizing agent. Oxygen gain the electrons released by the glucose. So oxygen is reduced during the process. There is also a respiration equation. For example, in the chemical equation, the oxidation where the glucose loses the electron, which is the C6H12O6. In the reduction, the oxygen gain electron and it is reduced. While the role of oxygen is oxygen act as an oxidizing agent in this process. There is also the redox in photosynthesis, like how plant prepare the food. The process where the plants use the sunlight to convert the carbon dioxide and water into the glucose and oxygen. The carbon dioxide is reduced during the photosynthesis. Carbon dioxide gain the electron and hydrogen to form the glucose. The water is oxidized, like the water lost the electron and the hydrogen released the oxygen as a byproduct. So during the energy absorption, this is an enterogonic process, meaning it required the energy from sunlight to drive the electron transfer. There is also the photosynthesis redox process, like C6H12, a C molecule of carbon dioxide and C molecule of water plus sunlight convert into C6H12O6, which is the glucose, and release the CX molecule of the oxygen. So carbon dioxide gain the electron and it become the reduced. So the water lost the electron and become the oxidized and glucose is formed. Now burning of fuel, how energy is released. For example, the fuel oxidation, when fuel like the petrol, gas or coal burn, the fuel is oxidized. During the energy production, the oxidation reaction releases a significant amount of the heat and the light energy. The oxygen's role is that the oxygen from the air act as an oxidizing agent and gaining the electron during the combustion process. In the chemical change, the carbon and hydrogen in the fuel react with the oxygen to form the carbon dioxide and the water. So there is some common examples of the fuel redox. For example, in petrol and gas, powering the vehicles through control combustion. In the coal, burning in power plants to generate the electricity. In natural gas, it's used for heating and cooking in homes. Redox in technologies like the batteries, for example, how battery works. It chemical to electrical like batteries use the redox reaction to convert chemical energy into electricity. The anode, which is the oxidation, so the negative terminal of the battery where a metal lost the electrons. In the cathode, which is the reduction, the positive terminal where a substances gain those electrons. So the electrons flow, the movement of electron from the anode to the cathode through a wire is what power our devices. There is some lithium ion example. For example, in lithium ion batteries, charging electrons are forced into the battery and discharging, for example, spontaneous redox reaction release the electron to power your phone or the laptops. During the redox reaction in human body, the role of the redox, for example, chemical reaction involving the transfer of electrons are fundamental to human body. During the energy production, our bodies are redox reaction to convert the food into unusable energy through a process called metabolism. In the survival, these reactions are essential for survival as they power every cellular functions. In the environmental importance of the redox, for example, how redox clean our world. In the natural cleaning, redox reaction play a critical role in cleaning the environment. During the water purification, oxidation and reduction process are used to remove the contaminants and pathogens from water supplies. In waste treatments, the redox reaction are essential in treating the waste material, helping to break down the complex pollutants into safer substances. In the atmospheric health, these reactions also occur in the atmosphere, helping to cycle elements and neutralizing the certain harmful gases. As a summary, there is some importance of the redox reaction, like it is essential for life. For example, metabolism and breathing are core redox process that are essential for human survival. Energy production, like redox reaction, power our world through the burning of fuels like petrol, gas, and coal. In the food chain foundations, photosynthesis is a critical redox process where plants use to prepare the food using the sunlight. In the environmental protection, these reactions are useful in water purification and waste treatments to help clean the environment. In everywhere around us, from the industrial production of energy to the natural process of iron rusting, redox reactions occur everywhere. So, as a conclusion, the power of electron transfer is that the redox is universal. As we have seen that the redox reactions occur everywhere around us, from the smallest cell in our body to largest industrial power plants. They having the life and energy, for example, processes like breathing, cellular respiration, and photosynthesis are the foundations of the life on Earth. There is some particle utility like our modern worlds rely on these reactions for burning fuels to produce the energy and for environmental purification. There is some final definitions like to summarize oxidations involve the loss of the electrons or the gain of the oxygen while reduction involve the gain of electron or the loss of the oxygen.